All right, example 5, we're going to take a look at a geometric sequence. Under what conditions on the real numbers r and c does the sequence defined to be cr to the n converge? So here we're talking about a sequence whose general term is going to be c times r to the n, where both c and r are just real numbers. So they could be positive, they could be negative. Okay, so if we want to figure out under what conditions does this geometric sequence converge, then we should take a limit of this. So CR to the n. Okay. So the first thing I'm going to observe here is that the value of C is not going to affect convergence. Because convergence has to do with what's going on as we look further and further down the sequence, down that list of numbers, arbitrarily far in that sequence, what's happening to the sequence terms. So this is controlled by the value of n, and n is only attached to the value r. So r and n are intimately connected, and the value of r will affect whether or not the sequence converges, but it's not going to be affected by the value of c. The only way it could potentially affect the convergence or divergence of the sequence is, for instance, let's say if we have a c value of 1, okay, so c equals 1, then really we just have the sequence r to the n. And let's suppose that this sequence diverges. But now what happens if we make the c value 0? Then we would have 0 times r to the n. Now we know independently of the value of c, this r to the n diverges. But if we multiply by this value of 0, then our list of numbers, our sequence, all the numbers are the same number, and that number is 0. So technically it could make the sequence converge, but only if that value of c is 0, which is a really hyper-specific example, and it's not really what's important here. All right, so barring that extreme example, let's just say only the value of r is going to be important here. So in this case, what makes... So I'm going to pull the c out. So I have c times the limit as n goes to infinity of r to the n. Now let's focus on this piece. Under what conditions does this converge? Or does this limit exist? Well, remember that a limit exists if it approaches a finite real number. So for instance, if I take r equal to 2, and then I think about raising 2 to arbitrarily large powers, then this right here is going to, in itself, become arbitrarily large, and therefore it would diverge. What about negative 2 to the n? Well, this would, not only would the terms in absolute value become arbitrarily large and diverge to infinity, but with this negative in front of it, it would also flip-flop between positive numbers and negative numbers. So it would diverge for a very different reason as well. Not only do the terms become arbitrarily large in absolute value, they are also going to two opposite directions. So definitely not honing in on a specific unique real number. But notice what happens if we plug in a value of r that is less than 1. So let's say a half. If I take a half and raise it to the nth power, so as n becomes larger, I just get 1 over 2 to the n. So if I made a table here for values of n, for n equals 0, we'd have 1. For n equals 1, we'd have a half. For 2, we'd have a quarter. For 3, oops, for 3, we'd have an eighth. The list goes on. These numbers are getting smaller and smaller and smaller, and they are honing in on the value 0. So really what we need here is this. So this would, there's two possibilities. If absolute value of r is greater than 1, if it's greater than 1, it will diverge to infinity. Or let's just say diverge. Let's just keep it simple for now. Say diverge. The other option is if r is less than or equal to 1, it converges. It converges. So even here, there's a couple options. So the one option is if r is negative, but in absolute value less than 1, then this would diverge to negative infinity. If r is positive, it would diverge to positive infinity. And this is assuming that c is the same sign. If c were negative, then the double negative would be a positive. So there's a lot that can happen with that value of c. And the other option down here with converges, if r is strictly less than 1, then it would converge to 0. And if r is exactly equal to 1, then it would converge to the value c, because we would really just have c times 1, c times 1 squared, times, or comma, c times 1 cubed, so on and so forth. Upon simplifying, we just have c's. So those are the conditions that we have convergence or divergence.